Good morning or afternoon, depending on what time you are viewing this. I apologize for being out today. I had not intended to be out today, but unfortunately needed to take care of some things. So I figured I don't want us to get behind, so I was going to just leave the notes as I've done in the past for us via an app called Explain Everything. So you should have a copy of this, hopefully. I sent it through email, and they were supposed to make copies and give it to the sub. So if you just watch and follow along, there are going to be times where I ask you to pause the video and work on your own, and then start the video again to check your answers. So let's get started. So we've been studying the Pythagorean theorem. We've been studying about proving the theorem that a squared plus b squared equals c squared. Then we've also learned to apply that both with just right triangles, finding the missing leg. Sometimes it's the missing hypotenuse, sometimes it's missing A or B side. And then we moved into word problems. So we may have rectangular scenarios where we have to find the diagonal. Think about a TV. And a TV is typically rectangular, laying on its side. Sometimes you can find, like, all TV measurements. If you have a 47-inch TV, it's not because it's 47 inches wide. It's 47 inches from the top left corner to the bottom right corner. It's across its diagonal. So being able to find those missing sides is a piece of that, especially when applied to word problems. So now we can still use this. The last standard we need to uncover and move forward with is the being able to find the distance on the coordinate plane. And it's easy to find, as you see in this first graph A, our first coordinate point is 1, 3. So just a quick review that the axis going across from left to right here is considered the x-axis. And let's just highlight that. This is the x-axis. And then the axis running north-south would be the y-axis. So when we find our points, we want to walk through the door. So you're going to start at the origin, and you're going to go start here at 1. X is 1. And what is y? Well, y is 3. So this point itself is the point 1, 3. This is the how far to the x and how far up the y. So when we want to count distance, is this circled point one step? Well, no, because we haven't moved anywhere. That's our starting point. We haven't actually taken a step yet. So this sometimes gets students. You have to count from the circle to the next spot where it touches the graph. That's 1. Then from this one to this one, this is 2. Then from here to here, this is 3. And if we look at the x-axis, we see that we started at 1 and we landed on 4. 4 minus 1 is 3. So the trick is to understand that you're moving from one point to another. And each hop, just like in scientific notation, each hop is one value. So this is a distance of 3 units. If each box was a centimeter, this would be 3 centimeters. If each box represented a day, this would be 3 days. So that's the big thing when you're moving left to right, or even north to south. Say the next dot was here, and we wanted to find the distance from my circled point down to my dot that I just created. It would be 1, 2 hops, so it would be 2 units. So the trouble comes, though, when you want to count from dot to dot on a diagonal. We can't just say, well, there's a box, and there's a box. It must be 3. It doesn't work that way. Because that's why a plus b doesn't equal c. It's a squared plus b squared equals c squared. So we can employ the Pythagorean theorem. And as we know, this point here is the hypotenuse. Because on a grid, we've just made a right triangle. So that's the nice thing about a coordinate plane, is that we have this right triangle here. Okay? So to find that, if I have 2 units down and 3 units across, I can certainly do 2 squared plus 3 squared equals c squared. Then I find that 4 plus 9 equals, c squared. and I have 13 equals c squared. I take the square root of both sides. So c is the square root of 13, which we can estimate. So that would be 9 and 16, be about 3.5. So we would be wrong if we tried to count boxes and say, oh, this is 1, 2, 3 boxes away. That's not the way it works. Okay, so now taking that point, and let's go into the other graph. So I kind of gave you a spoiler heads up here. We have measured from this point here down to this point here. It's a diagonal. We can't, as we just proved, can't count boxes. So then what can we do? Well, we have to create our triangle. So there would be the point that's most north of the point on the bottom and most far right from the point on the left. And so we have to actually create our right triangle here. All right, so now how many hops over? 1, 2, 3, 4. How many hops down? 1, 2, 3 units down. So this would be a 4 by 3. So what we're really though looking for is c. So this would be 4 squared plus 3 squared equals c squared, or 16 plus 9 equals c squared, or c squared equals 25, or if we take the square root of both sides, c is equal to 5. Okay, so let's read through this. We have sometimes finding the distance between the points on a coordinate plane is as simple as looking and counting the numbers of units, like in graph A. So all we had to do, just to be able to count that lateral movement, all we had to do was count the hops. 1, 2, 3. However, other times, we might need to find a diagonal distance, like in graph B. And that's where you have to do your hops. So then to find a diagonal distance on a coordinate plane, we can create our own right triangle. Please put that in your notes. And use the Pythagorean theorem to calculate the distance. So we're going to create our own right triangles and then use the theorem. The diagonal distance would then represent the hypotenuse, or side C. Okay, so use the Pythagorean theorem to find the distance between points A and B on each graph. Round your answers to the nearest tenth. All right, first thing you're going to want to do is create your triangle. If you want to, you can even pause this if you feel like you already have an understanding. If not, go ahead and do this one with me. Pause it, and you can try number 2 on your own. So let's see. If you're ready to try it on your own, go ahead and pause the video. Okay, so we're looking at point B, and I need to make a triangle. Does it matter if I put it here and create this right triangle, or if I put it here and create this right triangle? Oops, the answer is no, it doesn't matter which one I do. So what I'm going to do is just choose one and draw my right triangle. Well, there's my right angle here. And I've got to count my boxes. So I'm going to go 1, 2, 3, 4. There's 4 units on the horizontal and 1, 2, 3, 4, 5 units on the vertical. So now we're going to do, remember, a squared plus b squared, it doesn't really matter which one's side A or side B because the commutative property of addition. So we're going to do 4 squared plus 5 squared equals c squared. How do I know that it's side C that's missing? You have this right angle kind of pointing to the longest side. So if you can't really tell by visual, as we've seen, some of the skinnier triangles, C and B sometimes look very similar. So then you just need to square 4, square 5. And some of you guys like to add these up and put your answer of 16 plus 25 right here. And I would encourage you not to do that. I want you to just keep bringing c squared down. It's not that it's wrong, but the whole point is we're trying to balance the left side of the equation with the right side of the equation. So I'm trying to keep the value of the left side on the left side. So this would give me an answer of 41. So I'm going to keep 41 here on the left side because this whole side is equal to 41 and this whole side is equal to c squared, but we just don't know what, I mean, c squared is 41, but we need to now take the square root so we can find the value of c. And using estimating, we know that it's bigger than 36 but less than 49. I'm going to take my calculator and put in the square root of 49, and I mean not 49, silly, square root of 41. I was like, it's 7, it's a whole number, wait a minute. Square root of 41 is 6.4, or yeah, 6.40, but we're rounding the nearest tenth. So C is 6.4. Did you get that? If not, let's look back and find out why not. Check your work. And let's try another one. You can pause the video and try it on your own, or you can do this one with me. All right, so the first thing we need to do, we have a diagonal distance to find, and we can't do that without a right triangle. So we need to draw the right triangle. Okay, and this would be the C side, the side we're looking for. A side would be 1, 2, 3, 4, 5, 6, 7 units long by 2 units long. So 7 squared plus 2 squared equals c squared. Again, we're going to keep the value of the left side on the left side. What happens on the left side should stay on the left side. And, oops, always forget that little square. And now 49 plus 4 is 53. And so c squared is 53. So the square root of 53 is 7.28, also known as 7.3. All right, at this point, you should be able to pause the video and do the next one on your own. It should not matter that you're going to be crossing the x or y axis. Okay, so you've unpaused it, and you're back, and you're checking your work as I do it here. So to find this side, we're at 1, 2, 3, 4, 5, 6, 7, 8. Again, one of the biggest things I notice is that students will go and count like this. They'll count 1, 2, 3. No, we don't start here as 1. Okay, this is not 1. That is just your starting point. In order to count, you start here and go from here to here is 1. From here to here is 2. From here to here is 3. 4, 5, 6, 7, 8. Okay, starting at the next vertex, we're going to go from here to here is 1, 2, 3, 4, 5, 6, 7, 8. So it's an 8 by 8. Oops. So 8 squared plus 8 squared is equal to c squared. 64 plus 64 is equal to c squared. 64 and 64 is 128 is equal to c squared. Square root of both sides. C is equal to 11.3. All right, I'm going to pause this.